In this question, we're asked to determine the compound with the greatest lattice energy. And in a previous video, we discussed the properties that affect lattice energy, but I want to review them here. The first one, and the more important one for the lattice energy, and when I say more important, I mean has a larger effect, is the charge difference. So the greater the charge difference, the greater the lattice energy. The second one is the size of the ions. For ions that have the same charge difference, the smaller ions tend to be closer together and therefore have a greater lattice energy. So in order to determine this, let's first start with the charge difference. Rubidium here is 1A, so it's +1. Sulfur's 6A, so it's -2. Strontium is 2A, so it's +2. And sulfur is -2. There's a greater charge difference between +2 and -2 than +1 and -2. So therefore, strontium sulfide will have the greater lattice energy. In the next case, we have CaI2 and CaBr2. Ca is +2, iodine is -1. Again, Ca is +2, iodine is still -1, so these have the same charges. In this case, calcium is the same size, Ca2+, because it's the same ion. However, iodide is larger than bromide. So in this case, calcium bromide actually has the smaller ions. So the smaller the ions, the greater the lattice energy. Note that we only took into account the size because the charges were the same. In the last case, we have BeCl2, which is +2 and -1. And MgCl2, which is +2 and -1. In this case, again, we have the same charge differences, but magnesium is a larger ion than beryllium. It's one down on the periodic table. So again, we have the same charges, so we have to consider the size. And here, beryllium is smaller than magnesium, so it has a greater lattice energy.